Chapter 9 Space Weather 9.1 Activity of the Sun that affect Earth. The Sun appears as a ball of glowing gases as shown in photograph 9.1. The Sun consists almost entirely of two types of gases, hydrogen and helium. Structure of the Sun. The structure of the Sun consists of the part shown in figure 9.1. Carry out activity 9.1 to learn more about the structure of the Sun. Three layers that from the Sun atmosphere: corona, chromosphere, photosphere, conversion zone, radiation zone, core.
Granules, sunspots, and solar cycle. The photosphere in the Sun's atmosphere is made up of granules, which appears as grainy structures. The granules are the upper part of the convection zone of the plasma, which is extremely hot with a temperature as high as 5,800 degrees Celsius. The average diameter of a granule is about 1,000 kilometers. Sunspots are the dark regions seen on the surface of the Sun as shown in figure 9.2. Sunspots appear dark because their temperatures are lower than their surrounding areas, which are made up of granules. Sunspots are the location of very large eruptions in the photosphere. This phenomenon may last more than 1 week. Sunspots are phenomena that always exist in pairs or in groups. The activity of the sunspots seems to appear and disappear according to a cycle that lasts for 11 years, known as the solar cycle. Figure 9.3 shows the position of sunspots in the photosphere since 1875.
A prominent shown in photograph 9.2 is a huge lobe or glowing gases over the sunspot. Prominence can reach high of hundreds of thousands of kilometers and may last for several days and months. Prominence that are very strong can throw out matters from the Sun into space at speed ranging from 600 km per second to more than 1,000 km per second.
A solar flare shown in photograph 9.3 is a column of large amounts of charged gases erupting from the Sun and often occurs near sunspots. Solar flares are strong and spectacular explosions of gases. Solar flares attain their maximum brightness level within a few seconds or minutes and then become dim after a few minutes or hours. Solar flares spot charged gas particles at high speeds into outer space. The light from solar flares, which is at the speed of light, takes 8 minutes to reach Earth, while the charged gas particles take tens of minutes. These charged gas particles often collide with atoms and molecules in the Earth's atmosphere to produce a stunning light display in the sky known as aurora, which is uniquely occurs only in the airspace around Earth's pole.
Coronal mass ejection. A coronal mass ejection shown in photograph 9.4 is a huge cloud of plasma that erupts from the Sun and often occurs together with solar flares, which are huge and strong. A coronal mass ejection is an ejection of magnetic gas particles. The coronal mass ejection spouts magnetic particles at high speeds into outer space and appears like an expanding cloud. These magnetic particles from the coronal mass ejection take 3 days to reach Earth, like the charged gas particles in solar flares. The magnetic gas particles also react with atoms and molecules in Earth's atmosphere to produce aurora.
Particles in plasma such as electrons, protons, and alpha particles that erupt from the Sun to the outer space travel together at a high speed known as solar wind, as known in photograph 9.5. Solar wind also carries the interplanetary magnetic field along with it. The speed of solar wind is supersonic, with the value ranging from 250 km per second to 700 km per second. However, the speed, temperature, and density of the solar wind change along the course of its movement.
Earth's magnetosphere and its important. Shape of Earth's magnetosphere. A. Earth's magnetic fields. B. Earth's magnetosphere. Earth, magnetosphere, solar wind, and magnetosphere. Figure 9.4 Shape of Earth's magnetosphere. Compare and contrast the pattern of magnetic field lines between Earth magnetic fields and Earth magnetosphere. Even though both of these patterns of magnetic field lines are not physics, the pattern of Earth's magnetic field lines change slightly while the pattern of the magnetic field lines in the magnetosphere change a lot based on the interaction between solar wind and Earth magnetic fields.
Definition of Earth's magnetosphere. Earth's magnetosphere is defined as a region in outer space surrounding the Earth with the magnetic field in Earth's magnetosphere is combination of Earth's magnetic field as the prime magnetic field and the magnetic field in the region in outer space as shown in figure 9.4b. Formation of Earth's magnetosphere. Magnetosphere is formed by the interaction between the magnetic field brought by the solar wind and Earth's magnetic field. As the number and energy of particles brought by the solar wind change, the shape of the magnetosphere also changes.
Importance of Earth magnetosphere. The importance of magnetosphere is to protect Earth from the adverse effect caused by dangerous particles from the Sun or other bodies in the universe. Protection from Earth magnetosphere. Solar wind, magnetosphere, Earth protected, and magnetosphere. The magnetosphere function as biology shell to protect life on Earth from the adverse effect of solar wind. Block charged particles such as electron, proton, and alpha particles in the solar wind from reaching Earth. Excessive number of charged particles in Earth's atmosphere will disrupt telecommunication, navigation system, and electric power lines, reduce the pressure exerted by solar wind on Earth's atmosphere.
9.2 Space weather. Space weather and its effect on Earth. Space weather is defined as the phenomena that occur first on the surface of the Sun, such as solar flares, prominence, sunspots, and coronal mass ejection. In space, such as solar wind, solar radiation storm, and geomagnetic storm. Sunspot, coronal mass ejection, solar wind, Earth, solar flare. Magnetic field line, solar radiation storm, Earth. Magnetic field line, geomagnetic storm. Interpretation of data on space weather. Data on space weather is used or analyzed to forecast when coronal mass ejection occur in the Sun, determine the reason for the occurrence of solar flares, coronal mass ejection on the surface of the Sun.
Chapter 10 Space Exploration. 10.1 Development in Astronomy. Historical development of the Solar System Model. Ptolemy 90 to 168 AD. Greek astronomer, astrologer, and geographer. Built the geocentric model with Earth at the center and circular orbits. Geocentric model. Jupiter, Saturn, Venus, Sun, Moon, Earth, Mercury, Mars. Geo means Earth. Centric means center. Earth is at the center of the solar system. Earth is stationary and the objects such as the Sun and other planets revolve around Earth in circular orbits.
Copernicus, 1473-1543. Copernicus is a Polish astronomer, mathematician, and economist and a doctor, built the heliocentric model with the Sun at the center and circular orbits. The heliocentric model. Helio means the Sun. Centric means center. The Sun is at the center of the solar system. The Earth rotates on its axis and revolves around the Sun in a circular orbit.
Last is Kepler, 1571-1630. He's a German astronomer, mathematician, and astrologer. He modified the heliocentric model with the Sun at one common focal point on the elliptical orbits of the planets according to Kepler's law. Modified heliocentric model according to Kepler's law. 1 is Mercury, 2 is Venus, 3 is Earth, 4 is Mars, 5 is Jupiter, 6 is Saturn, 7 is Uranus, 8 is Neptune.
10.2 Development of technology and its application in space exploration. 11th century, Chinese invented gunpowder and used primitive rockets in battles. 1609, first telescope used in the field of astronomy by Galileo Galilei. 1957, first satellite, USSR Sputnik 1. 1961, first human to orbit Earth, Yuri Gagarin, abroad, USSR Vostoky. 1969, first human to set foot on the moon, Neil Armstrong, US Apollo 11. 1973, first Jupiter flyby, US Pioneer 10. 1981, first flight of US Space Shuttle Columbia. 1989, first Neptune flyby, US Voyager 2. 1990, US launched Hubble Space Telescope from Space Shuttle Discovery. 1996, Malaysian satellites MESAT 1 and 2 launch. 2000, Malaysia's first microsatellite Tung SAT launch. 2002, National Space Agency established. 2011, construction of International Space Station completed.